Welcome back, Physics 30. So last video we looked at adding two vectors if they should happen to form a right triangle using the Pythagorean theorem and trig. Now we'll look at adding two vectors that don't necessarily form a right triangle. We can still use a mathematical method here in terms of the law of sines and the law of cosines. So if you forgot what those are, I've outlined them over here. So assume I have a triangle like that. We can see that it doesn't form a right triangle, but we can identify various parts. Angle A and the opposite side of it would be called side A. Usually it's common practice to use a capital letter for the angle and a lowercase letter for the side. Angle big C and the opposite side is little c. Big angle B here, and the opposite side there is little b. So there's two relationships here. The law of sines, sine A over A equals sine B over B equals sine C over C. Those are equal. Or we could flip these upside down and have A over sine A equals B over sine B, etc. Then when you look over here, you can see there's kind of a modification of the Pythagorean theorem. If we're looking for side A, it's equal to B squared plus C squared sides minus 2 times side B times side C times the cos of angle A. So it depends on how you label it, which determines which one of these you use. Okay, so there are samples in the textbook you can look at. We'll look at two examples here. I'll go over one in detail, and then I'll leave you with the second one to try, and just simply give you the answer after. So if we take a look here, assuming you drive 15 kilometers east, then turn and go a further 25 kilometers, but this time in direction of east, 45 north. Make a sketch showing these two movements along with the resultant vector. What is the angle between the two movements in the triangle? So if we take a look here, we have our two movements. So I use this as my starting point. So 15 east, then you go from there, you draw your next vector, and if you look at the angle, from straight east, we go 45 in the north direction. So from straight east, we go 45 degrees north, and that's where we finish. So from start to finish is our resultant, and the answer to the question is, what is this angle in here? Of course, you can see these two angles are supplementary. They must add up to be 180. So if I take 180, subtract 45, I'll get 135, which is the measure of that angle in there. Okay. So on the next page there, we have another question here. Determine the resultant. So what is the resultant? If I just recopy the diagram up here so I don't have to keep flipping back on the page. The resultant here, now I labeled this, you could have labeled yours a different way, it doesn't really matter. So if I call this angle A, angle B, angle C, the sides that are opposite that angle are equal to the angle except the lowercase. So big A, big B, little b, big C, little c. So according to this, I'm going to be looking for little a. So going back over here, A squared is equal to B squared plus C squared minus 2BC cos A. So that's what I'm going to be using. So there it is. A squared equals B squared plus C squared minus 2BC cos A. So just simply substitute in everything. The difficult thing is just simply seeing which one goes with each label. So little b is 15. Little c is 25. B and C. And then angle A, which goes with side A, is 135. So you can see how I have that set up here. 15 squared plus 25 squared minus all of this once you multiplied it. So simplifying that, 15 squared is 225. 25 squared is 625. And if I just carry this negative down to here, then simply take 2 times 15 times 25 times the cos of 135. I get negative 530.33. And then, so 225 plus 625 is 850. Subtract the negative, because it's going to make that a positive. So I get A is equal to the square root of 1380.33. Take the square root of that, 37.15279. And of course, my sig figs here, I have 2 sig figs in each of these numbers, so my answer will have 2 sig figs as well. Keep the 3, keep the 7, the next digit's a 1, so this stays as 37. So we have the size of that side. Okay, now that we have that, we'll know an angle and its opposite side. And if we're to figure out the angle of the resultant vector, of course it's pointing this way, it's this red one, we have to figure out C. Big C, we know what little c is, so we're going to use sine A over A equals sine C over C. Okay, because those are the pieces that we know for that. So if I look here, sine 135 over 37, which I just calculated, so you do have to use a previously calculated answer here to make it work, equals sine C over little c, which is 25. So I want to isolate sine C here, sine C divided by 25. So to isolate sine C, multiply each side by 25. It cancels off here, and we're left with sine C equals sine of 135 times 25 divided by 37. So if you do that, we get sine of C is equal to 0.4777. And of course, take the inverse sine of that, and I get 28.5 degrees. And like over here, I rounded it off to 2 digits, 29 degrees. And if we take a look at our direction, east, and then that angle measure, north. So east, north is the direction, and that angle is going to be 29 degrees. Okay, so I'd like you to do this next question. So a hiker walks 4.5 kilometers south, then makes a turn and walks 6.4 kilometers south 25 west. Make a sketch showing these, and then figure out the resultant later on. First of all, just like the previous one, figure out the angle between the triangle. So pause the video now and see if you can fill in that. Okay, if you had an opportunity to finish that, this is what a sketch of the diagram should be. So 4.5 kilometers south is this green one right here. Then from there, you're making a 6.4 movement south 25 west. So from straight south, you turn your arrow so it's 25 degrees in the west direction. So this angle right here is 25. To figure out the angle in between the two vectors, of course, supplementary angles, 180 subtract 25 is 155. And I chose to label mine this way. Again, it doesn't matter. I chose this to be angle A and side A opposite. Angle B and B, angle C and C. And of course, to figure out what the resultant is, in my case, I'm looking for little a again. So the setup is something like this. I got 10.6 kilometers, so hopefully that's close to what you got. And then again, finding what the angle is, because a vector needs a magnitude and direction. So in mine, the way I label it, depends how you label it, you should get the same answer. Sine A over little a over equals sine C over little c. So using my numbers there, I got it to be 15 degrees. So in terms of direction, you can see the red resultant vector from straight south, we tilted it towards the west direction, and that angle is 15. So 10.6 kilometers south, 15 degrees west. So if you didn't get that, take a look at your work, maybe try it again. If not, ask me when you see me again, and hopefully we can get that straight as to why you didn't get that. But hopefully if you got 10.6 kilometers south, 15 degrees west, good job. Okay, we'll see you next time.